All right. Hi, everyone. Good morning, good afternoon, good evening, wherever you're joining us from, and welcome. Welcome to our Arm AI Tech Talk series. This is the place for the latest and greatest in trends, technologies, best practices from Arm and our ecosystem in this incredibly exciting world of AI. So particularly welcome to those who joined a couple of weeks ago, where we had a really interesting research topic. The YouTube recording for that is all live now, so you can go and check that out and dive into restructurable activation networks there if you'd like to. That was a couple of weeks ago. We've got a great talk coming up for you today on solving real-world challenges using AI on ARM, featuring an 18-year-old doing incredible stuff. Before we do get to that, I've just got a couple of the usual housekeeping things just to run through, which I'll cover on the next couple of slides. So I'm just going to talk through quickly how you can get involved and get in touch with us. So if we can go to the next slide, Blair, that'd be amazing. Thank you. You can, of course, not just get involved with the chat and Q&A, which I'll mention in a second, but you can tweet us at ARM Software Dev using the hashtag AIVTT. As I mentioned, all the prior recordings are live on our YouTube channel. Just after I finish my introduction, I'll paste the link for that in the chat box so you can check that all out and find all the recordings from past Tech Talks there. And of course, you can sign up for all our upcoming Tech Talks. We've got a bunch coming up for the remainder of the year. We're finalizing our schedule in November and December right now, and we've got a whole bunch lined up for January all the way into the middle of next year. So you can sign up for those at arm.com/tech talks if you like what you see today. So let's talk a bit more about what's coming up. If we can go to the next slide, I will talk through a couple of those. So today we are talking about how we solve real world challenges using AI on ARM with Neuton. So that's going to be a really great talk. I'm super excited for this one. What we're also then going to talk about in about 3 weeks' time, we usually do this on a 2-week cadence. We're going to do this in 3 weeks' time on October the 11th, is talking about TOSA, a new common operator set from ML accelerators. That's going to be from us, from ARM. So do check that one out. That's really excited about that one. And then we've got a short break for Dev Summit in late October before in November we carry on again with NXP and Arcturus talking about how they've done energy efficient ML vision app development on our Ethos U65 micro NPU. So if any of those sound interesting, the link to register is arm.com/tech talks. I will, of course, paste that in the chat as well, together with the YouTube channel link as well. So that's what's coming up. Really, really excited. I'm very excited. I hope you are too. Let's talk about today. Today, we've got a really exciting talk from our folks at Neuton.ai, one of our AI ecosystem partners. And I'm going to hand over now to Blair Newman, CTO at Neuton, sorry. And later on, you'll be hearing from Sumit as well, who's going to talk to you about some really interesting challenges they've been using Neuton TinyML, working on ARM processors, and how they've been solving these incredible real-world challenges. So, Blair, it's great you can join us today, and Sumit as well. Sumit's joining us from India, Blair from the US. So great to have you guys here. Enough from me. If you've got any questions, audience, you know where to post them in the Q&A box at the bottom. So, Blair, straight over to you. Take it away.
All right, thanks, Tobias. It's always a pleasure to have the opportunity not only to join yourself, but of course, continue to partner with ARM as we continue to grow our partnership and bring more and more value to the community. With that said, let's get things going. I believe that you've already kind of introduced ourselves, but just once again, by way of introduction, my name is Blair Newman. I'm the CTO here at Neuton. And joining me as a part of today's presentation will be Sumit, where he'll have the opportunity to share with you guys a real-world implementation, not only from a TinyML perspective, but of course, leveraging the Neuton platform and of course, ARM as well. And it's something that I have no doubt that everyone within the audience, whether you're here today or whether you have the opportunity to join us virtually after these particular Tech Talk is produced, I'm sure you guys will receive a tremendous amount of value out of today's discussion. So just to kind of give you a quick outline as to how today will work, I will spend just a few minutes just giving you guys just a brief overview of Neuton and our platform. But more importantly, I'll hand it over to Sumit, and he'll then have the opportunity to then share with you guys where he then leveraged our platform, leveraged ARM in a real world implementation. So that's something that we're pretty excited about. And then in addition to that, we'll have an extremely fantastic giveaway towards at a later date regarding 2 Arduino Pro boards and a couple of ebooks from Packet T. Now, just by way of introduction, for those who are newly introduced to Neuton, Neuton is a platform, an AI-based platform that really has been focused on fulfilling a singular mission. That singular mission is to bring AI, or to bring tiny ML, to everyone. And we've always leveraged or took advantage of that mission in a very literal way. And we accomplished this by doing a couple of different things. Number one, we enable everyone, irrespective of your skill set, whether you're a seasoned data scientist or if you're new to machine learning, to be able to produce extremely compact models in just one iteration. And by the way, we've eliminated all of the needs that you would typically, or all of the steps that you would typically go through, where you have to compress your models in order to integrate those models into your respective MCU. And so by doing so, we've enabled everyone to be able to take advantage of TinyML moving forward. And oh, by the way, you're able to take advantage of all of these features and produce a model of minimal size without compromising any accuracy along the way. Some additional things that we always like to highlight, you might also see it in my background, is that our objective is to redefine what TinyML is today. And in doing so, our platform produces models that are often less than a kilobyte in size. We believe that should be the new standard moving forward. And in doing so, oftentimes we find that our models are up to 1,000 times smaller or more compact than what you would find by leveraging other platforms or other technologies, say, such as TensorFlow. One more thing that I'd like to add is that all of our models that we're producing, you're able to integrate into 8-bit MCUs, 16-bit MCUs as well, which is something that you might find as a challenge today. And you're able to do this, once again, in one iteration. When we decided that we wanted to build out this platform, we wanted to be able to address some of the limiting challenges that you would find, whether you were using TensorFlow Lite or whether you were using non-neural network algorithms that are out there today. So we've combined the limitations, or we've addressed the limitations in both of those particular areas. And here we've had the opportunity to bring forth Neuton for all of you guys. And this is one of the things that we're extremely excited about continuing to share within the community, and we'll be able to put on display today when Sumit has an opportunity to demonstrate his use case in just a few moments. Now, what we're kind of seeing in the market, and hopefully you guys have had the opportunity as well, is that we're seeing that there's a number of different areas where you're able to take advantage of our platform. So whether it's predictive maintenance, whether it's some human interface use cases, or whether it's on the audio side, whether it's the classification of sounds, wake words, and voice activity detection. And Sumit will share with you guys, of course, what he was able to accomplish by leveraging the platform himself. But here's also one of the other things that we're extremely excited about, especially when it comes to beginning to really build upon our partnership with ARM. All of the models that our platform produces are basically silicon agnostic. So it doesn't matter if you're leveraging ST, Microchip, Arduino, Qualcomm, Renesas, you name it. Our platform natively, out of the box, as soon as you have the opportunity to download our models, you can instantly integrate those models and embed those models into any MCU of your choice. So all of our models that we produce are silicon agnostic. And that's something that we're extremely proud of as well. So just to kind of give you a quick overview, as I've mentioned, it's a completely automated solution. No experience is required. But one of the other things that I'm extremely more important about, I told you that our mission was to make TinyML available to everyone. And in one of the ways in which we accomplish this is you're able to leverage our platform in its entirety. It's free for all developers. So I'll say that once again, irrespective of where you may be in your journey, whether it's professional or business-wise, we make our platform available free for all developers. And that's something that we're extremely proud of as we continue to embark upon our mission of allowing for Neuton as well as TinyML to be available to everyone. So with that said, I believe that I've probably taken up enough of your time. I want to get to the meat and potatoes of today's discussion. And in doing so, I want to take a moment to hand over the screen to Sumit, who's done an exceptional job at producing at an extremely young age, in my opinion, an outstanding solution that I believe all of you guys will find value in. So with that said, I will hand it over to Sumit, and I hope that all of you guys will enjoy the presentation as much as I do. Over to you, Sumit.
Thanks, Blair. And it was really wonderful. So why do we need smart technologies in agriculture? So as we all know, our Mother Earth is under tremendous pressure. And according to Food and Agriculture Organization, by 2050, there'll be more than like 10 billion people on this planet. It means 2 billion more mouths to feed. And with each year, we are losing a lot of like agricultural lands due to like climate catastrophes, climate changes. And apart from that, there's also a rise in demand. But there's again, we need to ensure that we are protecting the natural resources because we have less land and more mouths to feed. It means we need to use resources wisely and we need to develop some smarter solution so that we can track or reserve or like you can tell that we need to save our resources that are going to be for the future generations. So the major problem which I was like dealing with during my like brainstorming of this project was production of fake pesticides. And this is a major issue in all the places or in all the countries. The companies spend a huge amount of money in R&D and all the investment to produce like pesticide or agro products which benefit the farming community and help to produce more yield per year or per hectare. But we are seeing that there are like many agents in the market that just making fake products, and they're hampering the farmer because the farmer might not know, and he might be using a fake or illegal chemical that might be harming his whole farm, and he might not know until the harvest season is done. So it's a double loss to the economy of the country as well as to the farmer and his families, and to us. We never know what we're eating and from where it came from. So this is the first problem statement for today. And in this one, we're going to address the problem during the transportation route of the agro goods. So what happens? The logistics of all this like fresh produce, or you can say the agro products, is very complex, and the member of each supply chain must work together so that they can be in the perfect condition. All the produce can be in the perfect condition, which means taking into account the temperature, packaging, and other factors. So in this case, we are going to talk about coffee Arabica, which comes in jute or sisal bag packaging. And the immediate requirement is free air circulation, which means a suitable temperature range, and the air quality should be monitored. In this case, we are going to use a microcontrolling unit based on ARM, and it is going to help us to understand that machine learning can help the companies or the agents to understand the emergence of unacceptable condition during its transit. The other problem today we are going to deal is about the counterfeits in the market. The thing that happens with all these products is they might be deliberately opened in the midway or in the route, and who we never know who is going to it might be dangerous opening in some geo restrictive environments, or maybe someone might be opening it to contaminate it, or just try to tamper the whole chemical produce. So there might be so you want to use a prototype so that we can seek ways to protect the end customer from counterfeit goods, and across the whole supply chain, we can validate the whole process of original fertilizers versus the fake fertilizers. That's very important. So in this case, we're going to develop a model which can detect the you can say the opening of the product, maybe unscrewing, or you can say opening of the packet or the container lid in this case, and deliver a dynamic notification. So usually there's a smart layout which I designed for and usually all the agro products like fertilizers, pesticides, insecticides, they all come in a package, and the package contains certain elements, like you can say the portions of the label, like the product name, compositions, and the info, etc. And they are very much required because the government has to like strictly moderate all these policies, how they are used and in what ways they are used, and the company must ensure that the farmers or the end users get to know the safety conditions for storing as well as for using it. So for our proof of concept, we chose Arduino Nicola Sense ME. Actually, the main reason for choosing this was because I was convinced that the sensors and the ARM Cortex processor, M4 processor, the lineup of ARM Cortex processor is very good and efficient enough for such tiny robust devices in such applications. Along with that, we get Bosch sensors, which easily integrate into like all kinds of application which we are dealing with, like monitoring the conditions, movement, etc. And with that, we also get flexibility of like connectivity and like a low power storage, low power power conservative. So there was another question for me: why does we thought of using Neuton with ARM? So the main question lies like there was a difference. When I started with non-ARM, the thing was there was a lot of learning curve in toolchain, compiler, developers, and when you change the vendor, it is totally impossible for you to start in the mid route. You just have to start from the beginning itself, learning the whole thing again. But with ARM Cortex, it doesn't matter. You can write your code once and deploy across all the Cortex M families, and it is very much optimized for low cost, because that initially when you think about non-ARM chips, they might be cheaper, but when it comes to ARM Cortex, you might be saving extra cost in toolchain, compiler, etc. Also, there is no need of manual optimization, and like they have very good support of software library and like high level language support. It means you get better performance compared to the price. So that's why I chose ARM for this project. And we are going to deal with two models, as I already started in the beginning. So these two models are like package opening detection and unsuitable environmental condition. So before we start with any ML model, it is very essential to understand what data goes into dataset collection step and like how we are going to utilize it. So for this one, we have two models, and the data collection was done on the parameters in the problem statements we already discussed. So we had temperature and all these conditions according and additional, we have container concealed and non-concealed you can say feature. It means your package might be just in the jute bag. It might be like a package which is open to air circulation, but in case of plastic bags or like very like airtight packaging, it might not be. So in that case, the temperature humidity might affect the package, but air quality cannot affect it. So in that way, the model was collected, and there is a target column, which means what prediction we are looking for. And at the same time, if we see the model to it only got three features, which are mainly from the motion sensor, X, Y, and Z axis. And if you see closely the picture, there is a like a border outline. It means there is a windowing done, which means like for how many like time period the motion or the like the activity was performed before feeding into the machine learning. So I created the model on the Neuton platform. Neuton supports three types of data, usually like audio data, sensor data, and tabular. As Blair already discussed, there is a wide support from the Neuton side due to the request of the people that they want to integrate the TinyML solution into audio classifications. But today we are going to deal with sensor data. Also, this tabular data, which is an auto ML solution, which is non-TinyML again, but it works pretty well with every kind of data set you have. Once you have the data set, you upload and choose the target. And yeah, the Neuton agent is very intelligent. According to your data set, it can classify whether it's a binary classification or a multi-classification. But again, you have an option for regression models as well. And there are a lot of metrics options according to your like solution. So this is for the second model we started. And in this case, we are using digital signal processing, which means like for all these sensors like we're using. So this one was the sample duration was around 3 seconds and the frequency of the sensor was 100 hertz. So it means that we're going to look for the motion or during the 3 second time period, and then only we'll be able to classify whether the seal was opened or in our case the lid was opened or not. According to that, we have feature extraction methods, and like there's a range of techniques one can use like for feature extraction. like amplitude, statistical, and frequency, and lot many options according to your platform requirements and your project requirements. So when I started with the training part, and yeah, it's a easy way, because and when we started with the training, we got the accuracy of around 99% for the model. And you can see there is a metric generated by the Neuton.ai platform, which is very helpful to understand from where your model needs to be tuned, or improvement of the model while it is training. And apart from that, there's a trained model C library, which is very essential for integrating our solution into ARM Cortex based MCUs. So yeah, the Neuton team has already worked, made our work easier, because while I was thinking of my solution, there were too many questions in my mind. The model footprint, how much space it would require. The model should not be very huge, because the Nicola has constrained memory, as well as that we need also application logic for all our apps, connectivity, and different blockchain protocol, which I was thinking in the beginning. But Neuton made it very much simpler for me. And it lists, it has a list of all the ARM Cortex processors which we can use for our solution, and you can check the total footprint it would require. So in this case, whether you are a embedded engineer, you are any hobbyist or enthusiast, you can get to know when you are going to need more space or more storage for your new microcontroller design or new project. And in that case, you can decide what kind of MC you want to choose. You want to choose ARM Cortex M4, M0, M3, or whatever you want. You want to go bigger and on the memory space as well as on the performance side. So it basically does that. So once you get this model and you're ready for embedding, so this is the extracted model which you download from other platform, and it contains 3 folders. So the first folder is actually converted models. So it contains might be your Onyx or PyTorch model that is generated from the platform. And then we have the Neuton folder, which is very much essential for our use case. So what is the advantage of using Neuton apart from all this TensorFlow? So this might be a big question for everyone, because we are talking about comparing the model size and all this thing, but we are not going to the initial stage. The initial stage, while I was struggling with, TensorFlow does not comes with a AutoML solution like Neuton TinyML. We need to predefine and pre-configure the neuron layer, and a lot of hassles to deal with, because you need to allot different neurons, different parameters, different optimizations, and then you come across then you come to reach a stage where you get good accuracy. But the limited time and for go to market to ready to go market solutions, you cannot wait for the whole iteration, because it would take a great deal of time. Bunching of neurons, designing it, and then doing the hit and trial method. And then the training is done, then you quantize it. Quantizing means just you lose on some precision, and you just shrink from the higher range of values to a subset, or a smaller subset of lower values, and you lose the precision as well. And once it's converted to a C array, then you deploy an ARM microcontroller. But in case of Neuton, this was very much simplified for me. I just had the data acquisition done and the training validation data set ready. And on the Neuton platform, I just had to go, and it starts automatically the neuron layer creation. And it is very intelligent enough to understand the underlying data and adapt to it. So with this, our model was very much accurate compared to other solutions, and it was smaller in size. Plus, we did not require any post-training quantization, which is usually seen in the TinyML kind of projects. It means I was not losing any kind of accuracy or any kind of result which I was expecting. I was getting that result. Plus, it also support 8, 16, and 32-bit. Imagine tomorrow you might be these all companies, they deliver the product in they have multiple SKUs, and tomorrow you want to develop a new product. So you don't need to worry about using 8, 16, 32 bits. You can deploy the model without any limitations, any factors like accuracy. So it works out well for all these kind of architectures. So when I started embedding to Nicola Sensemi, it showed me the this was the stats. So you can see the numbers are quite tiny, but the performance was great. If you see the inference time, it was 235 nanosecond and 231 nanosecond microsecond, sorry. 235 microsecond and 231 microsecond. It means it's a like very fast compared to the size that it is occupying. So this was the simulation of the project. So once you have the smart package label ready, the product which we have been discussing since the beginning, then any company like suppose Bayer and Bayer, they can use the product on their like products like because they have like bunch of SQs, seed growth chemicals and all these chemicals, and they can apply that label which I like a prototype of which I developed. So they can deploy it for environmental condition monitoring, package opening, and like if there's a problem from our like news, like if the model detects any kind of like detection, then it can raise an inspection alert. Suppose someone opened the container in between the transit, it was not reaching the farmer, and before it was opened, so inspection alert can be raised for the agricultural commission. There might be this kind of scenario where the agriculture commission can then intervene and then try to find a solution. Otherwise, if the status is very good, it can be done for the verified publication of the whole public, and the farmer can get to know from where the produce came, what was the condition maintained, and how the condition should be done for his like it can give a good insight if the product was delivered well without any contamination and in appropriate time, because for a farmer like he might be waiting for the whole season for his produce or like chemicals to come, and again he might be like needing it total transparency in the process. So here we give the control to the farmers for the whole process. So this is the demo of the solution. It was placed on the container. It's like a fertilizer product, and it was just trying to open it. So when you open or spray like chemical, so this was just trying to imitate a factor that if there was some condition like air quality level was bad or like any kind of like flammable compound were detected, it just notifies the user. And if the product was opened, it just prints a like log information that the product was opened. So basically the detection was done in the similar manner, like if the package or the lid was opened by twisting it, or like there are different techniques, and then it would detect if the product was opened. So coming to this, there are a lot of use cases, interesting use cases, which I am seeing from the like community side. And I have great interest in developing all these solutions that can benefit the society and environment. And I see this in the Neuton community as well. My colleagues and the community members, they're actively using the platform, and they're using the like platform to understand how they can deal with the this kind of global problems and how they can tackle it very easily. So now I'll hand over to Blair, and he will just like share some exciting good news for all the attendees today.
Hello, Sumit. Thank you again for such an exceptional overview of what you were able to accomplish. At least for myself, I found it to be very insightful, and hopefully I believe that the audience did as well. So just to I'll kind of skip through to the last slide, where we would like to share and announce with you guys an upcoming giveaway, which we will have. And give me just a second, and hopefully everyone can see my screen. So one of the things that I'm sorry, Tobias, were you going to say something? Okay. All right. I thought I heard you talking. So we have an upcoming giveaway where we will be choosing 12 lucky winners at random from all of the attendees. So out of the attendees that we have, 12 of you will be lucky winners. We will be giving out 10 ebooks specifically around IoT edge computing. In addition to that, we will be giving out 2 Arduino Pro boards, Portenta H7 Lite Connect. We will be announcing the winners on September 22nd on our social media page. And so you should be on the lookout for, and most likely we'll be doing it via via LinkedIn, and actually on all of our pages. And we also will be sending out a survey. We'd love to get everyone's feedback, not only in regards to the platform, but also we'd love to get your thoughts in regards to what you were able to get introduced today from Sumit.
Brilliant. Thank you so much. But I think actually that survey link is the giveaway form. So I will.
Oh, I'm sorry.
No, don't worry. I think, and people do get in touch with Blair, right? Do get in touch with giving feedback, because as you've seen, what a great, what a great demo, what a great use case, what a great example. And I hope that inspires you folks on the call today, whether you're watching on Zoom or on YouTube or wherever you're watching this from, when this goes live, on the recording of this goes live and will be up in YouTube forever, that you get inspired by this incredible example and just what you can do with AI on ARM together with companies like Neuton. I mean, they've done a fantastic job. Sumit, what a great example at such a young age as well. I wish I could have done that at 18. And it's just fantastic. So thank you so much for a great presentation. I'm going to do a couple of questions, and then I'm going to paste the link in the chat just to tease people out a bit longer. And also, as I'm sure there'll be some questions that people have that they want to ask, please just ask them in the Q&A box. I've got a couple on my side, just because I really think this is a great idea, and I think there's a great opportunity for you to learn a lot from it. So just remind me quickly, because I noticed a few people joined at about just after you finished speaking, though, just about halfway through your intro. What ARM IP do you support in Neuton? Because it was quite broad.
Sorry.
Oh, sorry, Blair, did you hear me? Sorry. I was saying, Blair, what ARM IP do you support in Neuton TinyML? Because it was quite broad when you spoke about it earlier.
Yeah, actually, so from a platform perspective, we don't have any limitations. So there are no limitations in regards to which IP we support.
Exactly, that's what we like to hear. So yeah, for you folks who just missed that at the beginning, I got a couple of chat messages about that. Then there's your answer. And Sumit, I've got a question on your side, and Blair, do chime in as well if you've got input. But since looking at these agricultural based, the agriculture products you're talking about, there's a lot of, I guess, restrictions and regulations based on geography, and they're going to vary from country to country, right? So will this kind of solution, or would this kind of solution work in different countries and using different TinyML models?
Yeah, I think that's a very good question, actually, because each country has a different requirement for labeling, for the labels of the product, as well as like the temperature and the condition requirements. Definitely, we need to use multiple models for the different like geo conditions, and it would be like making it more safer for these like products.
Brilliant. Thank you so much. And we've got some questions coming in the Q&A box, which I'll start asking as well, if that's all right. I've just added the link to the chat for the giveaway as well, so do check that out as well. Is C++ supported? What provisions are made for security? That's the top question we've got at the moment.
Yeah, I think Neuton built C library, and it is very much compatible with C++. You can use it with any IDE which you're using, or like microcontrollers. So pretty much, yes, it can work.
Yeah, thank you. I will just make sure we've got that ticked off. Let's have a look at the next question. What technology is used for the connectivity on the device? So what was the connectivity you mentioned?
Yeah, currently for the prototype, I just tried to use the BLE, or you can say low power Bluetooth module. But in case if you want to scale this product, maybe like low power connectivity would be much more like possible. Like the LoRa, Sigfox, and all these networks, they use like a very narrow bandwidth. So that is the main thing.
Okay, brilliant. Thank you. And then how many days does the environmental monitor last in terms of things like milliamp hour battery capacity?
I think this one would be like tough for me to guess, but according to me, like when I was testing the solution, we were not we were just checking the low power modules, and the Nicholas Sense was like a very low powered one, which was using very tiny like amount of milliamps of current for the these sensors. So I cannot give a good approximation like how many days or months, but yeah, it can like pretty much survive like longer duration.
Brilliant. Thank you so much. And how are you, oops, sorry, I've accidentally clicked one of the answers to the question, so apologies, I will just flag that one up. How are you able to deal with things like incorrect build variant or leftover compile options?
Sorry. Incorrect build variant or leftover compile option.
Yes.
I don't get this question. What does this question mean?
Yeah, sure. So apologies if I mispronounced the name, but Sheba, if you wouldn't mind just in the chat or in the Q&A box, just maybe clarifying that question a bit further, and then I'll come back to it in a second and we can ask Blair and Sumit that question. But in terms of, I have one other question as well. How are you able to kind of get these results, Blair, and Sumit as well, do chime in? How are you able to get these kind of results without talking about or mentioning, you may have mentioned, apologies if you didn't, but without using any compression techniques?
So yeah, I'll take that. So basically, so if you, let's say, take into consideration, how models are built today when you're, say, leveraging TensorFlow, which is oftentimes under the hood for most platforms that are out there, is that, you're typically starting off with a fully connected network. And then when you're starting off with that fully connected network, and once you reach, let's say, your requirements from an accuracy perspective, then you need to begin to take some additional steps to reduce the size of that model so that it can be embedded into your respective controller. And you may, say, use various compression techniques, which such as pruning, which will oftentimes result in, say, the loss of accuracy. But more importantly, you're starting off with that fully connected network. I like to typically say that that's a little bit more of a top-down approach. Neuton, we really have kind of just flipped the paradigm completely on its head. And our approach is that we build all of our models starting out with one neuron, and we go from there. So from one neuron to the next neuron, performing cross-validation along the way. So once we've reached the model to its optimal size and accuracy, it's already compressed, or excuse me, it's already at its most optimal size. So we never start off with a fully connected network, which allows for us to eliminate the need for any of those compression techniques.
Brilliant. Thank you for that answer. And I've just seen one as well that's just come in. Do you support CNNs? And I know Daniel's just answered it, but I'll make sure we just clarify this as well for folks who are scrolling down the Q&A, because we've got a lot of questions coming in. Does Neuton support CNNs for image or video analysis? So Daniel's just chimed in with that you can work currently with sensor data, audio and tabular data. Images and video are not supported yet. So just in case anyone's missed that. Blair, Sumit, anything to add further to that, or I can move on to the next question if not?
No, I think Daniel was pretty precise in his response.
So what about if you, and do keep the questions coming in, folks. We'll probably do another kind of 5 minutes or so of questions, I think is a good amount of time for this. And again, if you've got any more questions, do send them in, and we've got more tech talks coming up in the next couple of weeks, as I mentioned. So check those out on arm.com/tech talks, and don't forget about the giveaway in the chat as well. So what happens if actually, no, let's talk a bit more about Neuton, right? What are your real areas of focus as a whole for Neuton, Blair? Just to give people a bit more of an insight. What are the kind of main areas of focus for Neuton, and I guess your kind of work with ARM to some extent as well? Yeah.
So I like to always kind of answer this question, and where are we kind of seeing the most engagement, most traction? And I would start off by probably saying number one, on the audio side. So on the audio side, we're seeing a tremendous amount of whether projects within the community, projects with some partners that we have out there, and specifically, let's say with wake words, sound classification. But let's say the audio side is probably the area where we're seeing the most engagement. And then also, and I believe Daniel might have just touched on this, but also just in sensor-based data when it comes to, let's say, anything around predictive maintenance, et cetera. we're also seeing a tremendous amount of activity in that area as well. Those would be the top two areas.
Gotcha. And actually, we've got a couple of NLP questions that have just come in, Blair, that I'll ask you and Sumit as well. So the first one is, can we use Neuton for NLP? And then the second one is, when it comes to NLP, does Neuton process models completely on the board, or does some certain portion of that data need to be done online?
Yeah. So our platform, we have some limited support for NLP, but it is certainly not, I would say, that's not an area of our focus, but integrated into our platform. So when you kind of, let's say, take a look at our history, so Daniil mentioned that we're doing, let's say, audio, we're doing sensor-based data, and then also we do some tabular data as well. And this kind of just points to our background, where we were also working in other areas besides, let's say, just TinyML. Let's say maybe it's in the financial services side, et cetera. But so our platform, we do have some limited support for NLP.
Brilliant. Thank you very much for that. And the questions are still coming in thick and fast. So thank you, audience, so much for these great questions. And Mayank's come in with a question. Do you have on-device learning on your roadmap? And if yes, when could we expect it by?
Yeah, I think everyone, I mean, this is always a constant question. It was a big topic. I had an opportunity to speak at the TinyML event, foundation event. And this is just probably one of the most popular questions. I think this is on everybody's roadmap. And right now, we're not currently doing on-device learning. And so far, we have not defined a release date that we will have as it relates to this, but it's something that we're continuing to work on an ongoing basis.
Amazing. Thank you, Blair. And then we've got, I'll probably have time, let's do a couple more questions. And folks, last chance to get your questions in, so keep them coming. Can you use this neural network technique for object detection?
So now this will maybe give you a little bit insight into our roadmap. So on our platform, we do not do object detection, or basically we're not doing video, we're not doing images. But certainly sometimes when we have an opportunity to work directly with customers, which we don't do often anymore, a lot of times we're just working with partners, this is something that we'll do. But from a platform perspective, not at this time.
And look, Blair, Sumit, your talk is inspiring people. I've just seen the last question that's just come in. Are you looking to expand the development team? And if yes, where could I apply? It's amazing to see what Neuton's accomplishing. So Blair, Sumit, do you want to talk a bit more about that? Where can people apply if you've got any open roles?
Yeah, so, you can always go to our LinkedIn page. You can always go to Neuton.ai. But also, one of the things that we encourage everyone to do is to, when you sign up to leverage our platform, because it's free, certainly we look to have an opportunity to work with many more Sumits, right? So certainly sign up. We have a Slack channel that once you do sign up for the platform, you will join your own private Slack channel that includes Daniil, who's the head of our machine learning organization, myself is in the Slack channel. So we encourage everyone to sign up, and you'll have accessibility to all of us. And certainly, if we have an opportunity to work together, that can also be another platform where you can go to begin to interact. And certainly if something comes up, we'll be happy to entertain.
Amazing. Thank you so much, Blair. And thank you all, everyone, so much for your fantastic questions. It's always great to have so many audience questions that I get to ask and be the moderator for. Let's do a couple more, if that's all right with you folks. Let's have a look at Pallavi's question. Do you have any open source channel for development support?
Tobias, I think I can share one of my stories with Neuton when I started in beginning. So actually, when I joined Neuton, I was one of the ambassadors, and it was quite a proud moment for me, because Neuton was like quite a similar platform that was already the TinyML market, but I found a niche in the like developing TinyML solution because Neuton was a one-fit solution for everyone. I could iterate my projects faster, think of new ideas in a better way, because when the things are done automatically, you mean that you can experiment a lot of things. You mean you can combine a lot of sensor data, a lot of projects. And that's how I started. So maybe I would encourage everyone to participate in ambassador application of Neuton, and they might get not only the Slack, official Slack priority support, as well as you might be able to interact with me, Blair, and like everyone at Neuton and share your like journey, projects, etc.
Fantastic. Thank you, Sumit. That's great. And just one other compliment that's come in, Blair, that people are very honored to be part of this webinar, and thank you for being a symbol of Black excellence as well. So it's great that people are loving the content and asking so many questions. So folks, thank you so much for joining. Thank you for entering the giveaway. Blair, Sumit, what an awesome presentation. I mean, you really inspired the audience, because that's an incredible number of questions and a very active and engaged audience. That's what I love. That's why I love doing these tech talks, and it's why we keep coming back and doing these every couple of weeks. So I hope you've enjoyed today's content. And Blair, Sumit, thank you so much for presenting it and giving such a great presentation and great overview into Neuton, into AI, and to how you work so closely together with the incredible ARM technology that underpins all of this. So I hope it inspires you to go out and think what you can do next on ARM, what you can do next with ARM and AI, and what you can do next with ARM, AI, and with Neuton. So do check out all the links we posted in the chat. All the content from today, the slide deck will be uploaded very shortly to our developer.arm.com website. It's where we keep all of our content. So within about 24 hours, you'll be able to see the slides and go and check those out with all the embedded links in there for you to click if you did miss anything. We will also, the recording from today will be available straight afterwards, because we're live streaming on YouTube, which is great. So go and check that out. We're going to make a couple of edits, put some timestamps in the next few hours. So you'll see a very rough and ready recording immediately, and then a couple of tweaks within an hour or so. So do check that out if you've missed any part of today for whatever reason. And do catch us in 3 weeks time, not the usual 2 weeks, but 3 weeks time on October the 11th to hear about a really exciting new initiative called TOSA from ARM that you'll be, I'm really excited for, and I hope you are too. So Blair, Sumit, thank you so much, and the entire Neuton team for a fantastic presentation today. Really great, engaging content. I've loved hearing it. I've loved hearing from you guys present, and look forward to speaking to you all again soon. And audience, thank you so much for your great questions. We'll see you soon.
All right. Thank you.
Thanks a lot. Thank you, everyone.